All right, so this is the log review. I'm going to try to go through it as much as I can. I'll try to get the first page done here. All of these things are things that are on the test. So first one is being able to go and condense a logarithm. So the first thing you're always looking for is there any number out in front. You need to take care of that power property first. So in number one, you would write this as log base 3 of x to the negative second plus log base 3. I'm going to write this as x to the 1/2 because that's what the square root of x is. And then that all is going to be raised to the third power because we're bringing that 3 up front. So then I look at this and I have a plus sign. So the product property says I can rewrite this as one logarithm, same base, of the product of these two things. So I'm going to take x to the negative second times, this would be x to the 3/2. That's the product property, combined as one logarithm of their product. Now I just have to simplify that. If this is negative 4/2, remember I'm adding the exponents when I'm multiplying like bases, so I get x to the negative 4/2 plus 3/2 to be negative 1/2. And I should simplify that. That negative means it should be in the denominator. The 1/2 means I'm taking the square root. So my final answer is log base 3 of 1 over the square root of x. All right, number 2, same kind of thing. I see I have a 2, I have a 3, and I have a 1/2. So I take care of that first. So this is going to become the log of 2 squared, which is the log of 4. This is going to become the log of x to the third. And then this is going to become the log of this x plus 3 raised to the 1/2, which really means I'm taking the square root of x plus 3. All right, and then I see that I'm adding these, so product property says I'm going to multiply those. And then the minus, anything that's negative means it has to be in the denominator because you're dividing, so that's going to go in the denominator. So I'm going to have the log, so these are all common logs, of 4x to the third in the numerator over the square root of x plus 3 in the denominator. All right, so basically it doesn't matter any order. Anything that's plus positive is going to be multiplied on the top. Anything that has a minus in front of it is going to end up being in the denominator. Okay, so that's how you take more than one logarithm and condense them into one log with that base. All right, 3 through 8 is solving equations, finding exact answers. Now this says use your calculator, which you can do for the review, but on the test you will not. It's going to be all non-calculator. So I won't go through using your calculator, but using your calculator just means plug it back in and see if you're correct. Okay, so number 3. Number 3 is a log equation. And so a couple different kinds of log equations to look at. So if you have a log equaling a number, which is what this one is, then you always want to just put it in exponential form. So x raised to the negative 3/2 power has to equal 8. Okay, so anytime you have the log of something equaling a number, then you want to put it in exponential. And so this is an equation we should know how to solve. If you have your variable as your base and it's raised to this power, if you want to get it to be x to the first power, we need to raise this to the negative 2/3 power. So that's what we have to do over here, raise it to the negative 2/3. Because remember, you always want to get x to the first power, and that's what you're going to get there. You're going to get x to the first. And so I now know I have x to the first over here. Over here I'm going to have to decide what does that equal. So that the 3, the third, means I'm going to take the cubed root of 8, and then I'm going to take that answer and raise it to the negative second. Cubed root of 8 is 2, so I really want to take 2 to the negative second power, which is 1 over 2 squared, which is 1/4. Okay, so we put it in exponential. Make sure you know what to do to solve an equation like that. All right, number 4. Looks like I can get common bases. It's an exponential, but I think I can get the same bases, or I know I can. 4 is 2 squared, and the other one is just 2 to the first. And so now I have a power to a power, so I'm going to multiply those exponents. So I'm going to get 2 to the 2 minus 4x equals 2 to the first. And since I have like bases, I know those exponents have to be equal. And now I just solve that equation. I subtract 1 and I divide by 4. Oh, I also get an answer of 1/4. Not all your answers will be 1/4, so make sure you realize that just kind of happened there. 5 is a log equation. You're adding these two logarithms together, so that means we're going to multiply. And if I multiply those together and FOIL things out, I'm going to get x to the 4th. I'm going to get a positive x to the 3rd and a negative x to the 3rd. They'll go away. And then I'm going to get a negative x squared. So that's what I get when I multiply those two together. Again, this is a log equation equaling a number. So I'm going to put it in an exponential. 1/6 to the negative first power equals x to the 4th minus x squared. 1/6 to the negative first is 6. So I really have 0 equals x to the 4th minus x squared minus 6. Because remember, that is 6. And so this is a quadratic. You should be able to factor it. If I take x squared times x squared, I'm going to get x to the 4th. To get negative 6, I'm going to take negative 3 and plus 2. So I get x squared equals 3. So x is going to equal plus or minus radical 2, or radical 3, sorry. And over here I'm going to get x squared equals negative 2, and that can happen. So we do need to make sure if we plug it back in, we don't get a negative. So the log of square root of 3 squared would be 3. So I'm going to take 3 plus radical 3, and this would be 3 minus radical 3. And they both are going to be positive, so I'm okay in my domain. So both of those answers work. Number 6. 6 is an exponential equation. This one I can't get the same base, so I'm just going to put it in log form. Log base 5 of 100 equals x. And that's it. That's all I have to do. You know, you could change a base and say it's the log of 100 over the log of 5, but you don't have to. I'd accept that answer though. Log of 100 is 2, so 2 over the log of 5 is another acceptable answer. So any of those work. I would assume most of you would just stop there. Okay, so if it's in exponential form, put it in log form. If you can't simplify it, then you're done. All right, number 7. 7 is an exponential. Before you can solve it, though, you got to get rid of the 6. You've got to get the base by itself. So I get e to the 3x minus 1, I can't read that, equals 5. And now I put it in log form. Log base e, so natural log of 5 equals 3x minus 1. Solve for x, I add 1, and I divide by 3. And there's my value for x. And again, without a calculator, I don't know what that approximation is. I just know that's the exact answer. And then the last one on this page. I see a number in front, I see a number in front, so I have to take care of those. So I get log base 5 of x squared equals the log base 5 of 4 to the 3rd power. So 4 times 4 is 16, times 4 is 64. So then I get x squared, because the logarithms are equal, those two things have to be equal, so x squared has to equal 64. Square root of both sides, I get x equals plus or minus 8. But remember, we have to try to plug it back in. Here I'd be taking the log of 8, which is okay, but I can't take the log base 5 of negative 8. So the negative has to be eliminated, so only x equals 8. So I think I'll stop there, and then I will do the second page.